All right, so I've got this recording set up. We'll address the agenda here real quick. You can see we've got 2 breaks built into today. And we're going to start off with Parks, talking about a whole bunch of things. He's going to start out with an introduction to the agency and how, a lot of the particulars about the National Weather Service, what we do, how we're organized, all of that. Then some decision support services, including, services we can provide directly to school districts. Probabilistic forecasts. He'll explain to you what that means. We'll take a break after that. Then I will be talking to you about tropical products and timing, since we are in hurricane season and there is a potential area of development out there. Then we'll take a break and I'll come back with a session on severe weather products out of the Storm Prediction Center and excessive rainfall products, including timing these things out and for decision-making purposes. And then we've got a good chunk of time at the end. We'll stop the recording at 11:50, and we've got a whole 40 minutes scheduled there for a back and forth discussion. At that point, once the recording stops, feel free to turn your camera on, all that, and we can talk back and forth. So without further ado, and Parks, I'll take over the adding folks in as they try to come in now that it's your turn to speak. So I will stop sharing.
All right, sounds good. Thanks, Mark. All right, let me get my screen shared here. All right. Everybody can see that all right. Can you hear me okay, Mark? All right, sounds good. All right, so I'll get started here. Again, my name's Parks Camp. I'm the Science and Operations Officer here at the Weather Service office. So I help coordinate training, help coordinate scientific stuff in the office, do a lot of our internal training as well. So I've been at the office here for I think 17 and a half years, almost 18 years, something like that. Been in the Weather Service over 25 years. So I've been around for a little while. And so I'm going to talk a little bit today. I'll give you a little bit of an introduction to the Weather Service. We may have some people that aren't super familiar with the Weather Service and how we're structured and kind of what we do on a day-to-day basis and that kind of thing, and kind of who we are. So I'll talk a little bit about that, and then get into a little bit more of the meat and stuff like that. I did want to talk a little bit about the Google Meet stuff in case you're not super familiar with how Google Meet works. If you haven't used that a whole lot, get rid of that. So along the bar down at the bottom, you'll see kind of the controls for your Google Meet. So you've got microphone control there. Get my pointer up here. All right, so you got your microphone control there. You got your camera control. Again, we're asking you to keep your cameras off on here since we're recording the call, recording the webinar. So we're going to ask you to keep the cameras off. And then you've got reactions there if you want to do reactions or anything like that. There's the raise hand button there. So if you've got a question that comes up, you can click on that to raise your hand. But we also have on the right-hand side over there is the little chat button there. So if you've got a question that you want to type into the chat, so we'll be monitoring the chat as well. So if you want to type in a question into the chat, we'll try to get that answered. So we'll have some question time kind of at the end of each of our presentations. You're welcome to ask questions then, and we're also going to have some discussion time at the very end as well, after we kind of turn off the recording. So we'll have some general discussion time at the end of that as well. All right, so that's kind of the overall logistics for Google Meet. Again, kind of going back over the agenda a little bit here. So I'm going to talk a little bit about Weather Service overall, and then talk about decision support, and a little bit overview about probabilistic forecast and messaging. We have a little break. Then Mark's going to talk about tropical products, and then he'll talk about some severe weather products and that kind of thing. And then we'll have a little wrap up after that. So, quick little introduction to the Weather Service and the forecast and warnings overall that we do. So, Weather Service is a federal agency. So we fall under the Department of Commerce, which kind of surprises people sometimes. Figure out we're in the Department of Commerce, and underneath that we're in NOAA, so National Oceanic and Atmospheric Administration. So the Weather Service is one of a couple different offices underneath NOAA. So it's you've got National Ocean Service, Marine Fisheries, and then there's like the satellite office. That's the one next to us there, and there's several other offices there. So we're one of those offices. And then within the National Weather Service, there's a number of offices there. So we're locally here. We're one of the local weather forecast offices here in Tallahassee. There's also several other components to the Weather Service. These are just a few of them. But you've heard certainly of the National Hurricane Center. That's part of the Weather Service. The Storm Prediction Center out in Norman, Oklahoma. And then there's the Weather Prediction Center. That's up in the DC area. You also have river forecast centers. Our closest one here is up in Atlanta and Peachtree City. So those are all components of the National Weather Service that we all work together to produce the forecast and produce the information for you. Our overall mission statement, this is kind of what we base everything we do on. All our products that we put out, all our decisions we make are kind of based on this. So we provide weather, hydrologic, and climate forecast and warnings, impact decision support services for the U.S., the protection of life and property, enhancement of the national economy. So everything we do is based on protection of life and property, and that's kind of what we base everything on. So we do operate 24 hours a day, 365 days a year. So we're always here. Somebody's always here, ready to answer the phone, has an eye on the radar, always ready to take care of any problems that arise. So we have, in terms of the field offices, we have 122 field offices across the country. Ours, obviously, we're in the Tallahassee down here. So Florida's got 7 offices that cover parts of Florida. For Georgia, there are 6 offices that cover parts of Georgia. And then for Alabama, there's 4 offices that cover parts of Alabama. So that's how things kind of break up there. So, and this is where we cover Tallahassee there. So outside of the field offices, there are also national centers that focus on specific things. So you're familiar again with the Hurricane Center. So they're down in Miami. So obviously they focus on the hurricane forecasting and the tropical forecasting. There's the Storm Prediction Center out in Oklahoma. So they are focused on severe storms, tornadoes, severe weather, that kind of thing. But also they do a lot of fire forecasting as well, weather forecasting as well. There's an aviation weather center out in Kansas City, focused on aviation weather. And then there are several centers in the DC area where our headquarters is, but that's where the modeling focus is up there, and some other things. It's also a space weather prediction center out in Boulder, Colorado. So they focus on like solar storms and stuff like that, things that would impact satellites and solar storms and those kinds of things. So, we've had down here, rare occurrences where we could see the auroras over the last year or so. So they deal with stuff, the solar storms and stuff like that cause the auroras and stuff like that. So that's the Space Weather Prediction Center there. There's also a few others like the Tsunami Warning Prediction Center and things like that as well. So focusing in a little bit more on the Tallahassee area that we forecast for. So we forecast for parts of 3 states. So we've got the parts of the Panhandle, Big Bend, Southeast Alabama, including Dothan, Enterprise areas up there, Southwest Georgia, including Albany and Valdosta, and then also out over the marine areas as well. So we've got 3 states, 2 time zones, which makes things kind of fun and complicated all at the same time. almost 2 million people in the population areas that we cover. 48 counties, a lot of those in Georgia, thanks to all the small counties in Georgia as well. So we've got a pretty diverse area that we cover in terms of weather as well. So we are located on the Florida State campus. We've been here since the early 2000s in the Love Building on campus here. So that's a picture of our operations floor on the campus here. So we've got pretty decent sized operations area there where we do all of our operations, 24/7 operations. Now here's kind of what our staffing profile looks like when we're fully staffed. We have 14 full-time forecasters or meteorologists in place, and they are working 24-hour coverage, so rotating shifts. And so those are day shifts, evening shifts, and midnight shifts. And then in addition to those full-time forecasters, we have an observation program leader who's keeping track of our observation program, a hydrologist, an IT, keeping our computer systems up and running. We have electronics technicians who's keeping all of our things operating. So like our radar, our systems at the airports running, those kinds of things. Have an admin assistant who is certainly invaluable in keeping our day-to-day operations going. And then we have 4 members of management. So Mark and I are members of the management team. So we have different roles. So Mark works more with our external partners on the outside, and then I work internally more in terms of training and science internally. Felicia Bowser is our meteorologist in charge, so she's in charge of the whole office here for Tallahassee. Then we have our electronic systems analyst, and he manages the electronics team, who does the maintenance on all of our equipment. So that's our staffing profile here at the office there. So these are all the different types of duties that we take care of as meteorologists here. We do aviation forecasts for 5 different airports across our area. So all the airports in the area that have commercial operations, we do forecast for there. We do observations. Normally in normal times, we do upper air observations with balloons. We haven't done those in about a year due to a helium shortage. But we also have observation stations at different airports, and we do rainfall observations here on site as well. We do hydrologic forecasts, so we do river forecasts, and we also do warnings for flash flooding and other types of flooding as well. We do marine forecasts for offshore waters. We do our 7-day forecast as well, rain and temperatures and that kind of thing. We do fire weather forecasts, so we do routine fire weather forecast for our fire weather partners, so the state and federal forestry partners. We do forecasts for wildfires when those break out as well, so we do site-specific forecasts for those. And then we certainly do our warning responsibilities as well for severe weather and that kinds of things. And then what we're going to talk a lot more about today is our decision support services. So these are our partner-focused services, providing support services for our partners. So we'll talk a little bit more about those. So we kind of call those impact-based decision support services, or IDSS. And these take on a lot of different forms. Our overall definition of this, and I'll kind of read this. IDSS is the provision of relative information and interpretive services that enable partners to prepare for and respond to extreme weather, water, and climate events for the protection of lives and livelihoods. And so this is where you guys come in our relationship with our partners. We'll be able to help you, provide you the information you need to make the important decisions that you are making. So not make the decisions for you, but provide you the information that you need to help make the decisions that you need to make. And this comes in a lot of different forms from us. And some of the examples in pictures here primarily two different roles that we take in this, and primarily most of the time it's in a remote form of decision support services. So this could be as simple as a phone call where you call us and ask us for information, and we provide it there. Could be email as well. So could be simple example of phone call DSS is having an emergency manager call us and say, hey, they've got a big outdoor event going on, and they're concerned about approaching thunderstorms and need to know the timing of those thunderstorms in terms of evacuating or getting people cleared out of the area before the thunderstorms arrive, that kind of thing. And then we have other events where we've got days of planning to make sure that they've or are prepared for any dangerous weather that may occur for an event. So in those cases, we may provide emails ahead of time, those kinds of things. So we might have emails. If there are bigger events coming up, we'll do webinars. So we'll have these for severe weather events, winter weather events, and tropical events. So these are all types of remote DSS. As we oftentimes for tropical events, we have something called pods, where we're providing a Google Meet room where our partners come in. County emergency managers are able to come in and meet with us anytime during an event, ask us questions about what's going on, anything like that. There are times where we provide on-site DSS. That's where we actually send a meteorologist to either an event or an incident command post or an EOC or something like that. And so that's kind of another level of decision support that we can provide here. There's a couple examples of that you can see in the pictures. So we might do this. So for example, with FSU for football games in the fall, provide this for public safety purposes. We'll provide meteorologist for that. Up here in the top right, you'll see this is one of our meteorologists on site for a large wildfire response. There, providing decision support services. There is providing a briefing for Insight Command there. For Hurricane Michael several years ago, we had deployed meteorologists at the EOC in Bay County and also here in Leon County as well. So those are all different levels of decision support we can provide, all the way down from a phone call to actually deploying meteorologists on site. So it varies quite a bit. Now, to help us provide the DSS that you as our partners need, it's critical that we know exactly what you need to know. And that's where you kind of come in. So I'm asking you at this point to kind of think about, okay, what kind of thresholds, what kind of needs do you have? And we'll kind of come back to this at the end, later at the end of our session here early this afternoon, I guess it will be. And we'll come back and kind of discuss this and get some feedback from you if we can. And so think about what are your critical thresholds? What are your temporal and spatial needs? What are your what kinds of things are operationally significant to you? And what are your operational time periods? Because these are things that are helpful to us to know, so that we can provide you the information that you need. The critical thresholds are especially important to know, so that we can tailor our messaging to you. And so, one of the things we have a form that we can that we have for our partners to request decision support, and there are specific questions on that form about, okay, so what thresholds are critical to you? So is there a wind speed threshold? So is it what wind speeds are critical to you? Is it 30 miles an hour? Is it 35 miles per hour? Is it sustained winds that are important to you? Is it gusts that are important to you? those kinds of things. Is there a temperature that's problematic? Is lightning important to you in this case? So those kinds of things are things that we need to know. Not just is it going to rain or not, or things like that, because otherwise we can tell you all day there's 30% chance of rain, but if that's not really important to you, or we can tell you the winds are going to be 15 miles an hour, but if that's not really important to you, that doesn't really do you any good. So these things are important to you. Things like what's your temporal and spatial needs? Well, we need to know when are those things important to you. Is it important to you now, or is it important to you 2 days from now? What time of day is it important to you? Is it important to you early in the morning from 5 to 7 a.m.? What time are the school buses running? Those kinds of things. Or does it matter as much by 10 a.m. when everybody's already in school? Those kinds of things. Those are important as well. Those are important things that we kind of need to know. And we can tailor our decision support for that. So these are all kinds of questions to kind of think about. So what's important to you? And so I've kind of mentioned kind of some of these thresholds as I've gone through, and it varies from event, partner to partner, and event to event. So when we work with the city of Tallahassee, especially in the wintertime, we have a threshold of parent temperature or wind chill of 35 degrees, and that's important to the cities. That's when they start dealing with opening shelters and those kinds of things. So we know when we're getting around that threshold that we're going to be providing more decision support services to the city of Tallahassee. Now we know that for schools, depending on the district and depending on where they are, somewhere around 35 to 40 mile per hour winds or wind gust is kind of a threshold, and those kinds of things. So those are important thresholds there. As you get a little bit farther, we get into the winter as well, we got a little farther north typically, but then you have thresholds for snowfall and those kinds of things. Are there, thresholds for lightning, radii, and those kinds of things? Those are all important thresholds that are important for us to know and to understand with our partners. All right, so in general, so these are our general briefing criteria that we use for overall briefing when we go out and start doing either our email briefings or our webinars. So it differs a little bit between like a tropical situation, severe weather situation. So Mark's gonna, I think, hit on these again as when he does his session. So you'll see this all again. But could be pertinent later on this week. We'll see. So hopefully not. But we've got if we have a system out there and we get within that 5-day cone, you're definitely going to be seeing at least email briefings, probably webinars in that case. In most cases, some cases maybe not. Once you get, and then certainly an increase in our social media, that kind of thing. Once we get into that 3-day cone, so within about 3 days of that cone, you're definitely going to be seeing the webinars. Generally in the afternoon is the time frame we're going to be doing those, the 2:30 p.m. And then as we get into the watch warning phase, once we see watches and warnings pop up, you'll probably see a lot of times multiple webinars going on by that point, and possibly even more than that. So sometimes we'll have an evening webinar after that afternoon advisory comes out if there are changes to watches and warnings. So things will increase quite a bit usually when we get to that watch and warning phase as information starts to change more rapidly. So we'll certainly see email briefings probably start out a little sooner as we start to get things start pop up in the tropical weather outlook and start to look a little more certain. For severe weather, we take a look at the severe weather outlooks from Storm Prediction Center, and we kind of use their criteria as our guide for our email briefings and our webinars. And this is kind of a general outline of how often we see these different categories, and I think these may be mainly for Leon County, but roughly the same for the rest of the area as well. So we see lots of marginal risk every year. So especially in summertime, we get those, sometimes once or twice a week, it seems like. Anyway, Mark, do you have something there?
Yeah, the ranges you see in that return frequency column span the entire 48 counties, highest northwest, lowest to the southeast. So those are broad ranges across the entire 48 county area.
Gotcha. Okay, thanks, Mark. Yeah, so that's so lots of marginals every year, and with marginals, anytime we see that marginal risk, we're going to at least probably have an email out in the morning when we see those out, and that'll give you a kind of a rough idea of where we're expecting the severe weather, and the rough timing. Sometimes this time of year, it's kind of hard to nail down specific timing because a lot of times it's going to be just afternoon to evening kind of thing like that. As we get to Slight, probably ramp up the email a little bit, and then depending on the situation, we're not always going to have a webinar for Slight risk. It'll depend on how we assess the overall risk. If we assess it to be kind of a more significant risk, then we'll do a webinar. If not, we may just stick to an email briefing in those cases. Now, once we get to an enhanced risk, those are much more rare. So you're going to get generally a couple of those a year or less, depending on what part of the area we're in. You'll definitely see webinars for enhanced risk, and multiple email briefings a day for those. And then, moderate and high risk are quite rare in our area. We don't see many of those. Every year or two for a moderate risk, and then only every 10 to 15 years for a high risk. So those are extremely rare, and we'll ramp up things quite a bit for those two situations there. So you'll see typically multiple webinars and lots of information coming out of our office for those types of things. All right. For excessive rainfall and winter weather, excessive rainfall, usually that's wrapped in with either severe weather or a tropical event. We usually don't do a webinar or anything just for excessive rainfall unless it's a particularly rare event, in which case we might do something like that. But you might see briefing packets or something like that, or emails coming out for excessive rainfall. And then for winter weather, more of a case-by-case basis, depending on how significant the winter weather is. Obviously, for something like we had this past winter, we were doing more webinars and that kind of thing. It was quite a rare event. But those are more certainly the winter weather, more rare event. All right, so I'm going to stop there a minute and see if there are any questions so far on the decision support part, or anything like that. So any questions so far? All right, so not seeing any hands up yet, not hearing anything yet. So we'll move along a little bit here. So being the science and operations officer, I'm going to do a little bit of science here, and just do a little bit of an introduction to some probabilistic forecast and messaging. And the reason I'm doing this is that you are going to see a lot of our products have probabilities in them, and sometimes that can be a little bit confusing as to why why don't we just say it's going to do this or it's going to do that, but we do use a lot of probabilistic messaging in our forecast, and so I want to do a little bit of an introduction to some of that. I'm not going to go too in depth, but I'll take it into do this for a few minutes. So deterministic, when I say deterministic, that's kind of our single value forecast. It's going to be 95 degrees today. So that's a deterministic forecast. Okay. That doesn't always give the whole picture. Okay. Because we're not always, can't always be that certain about things, especially, there's a lot of uncertainty, especially as you get farther out in time, in terms of what the weather is going to do, especially, some of these bigger systems. So probabilistic messaging allows for us to better tailor our message, allows us to tailor a message to your thresholds and to our partner thresholds. And so we'll talk about that a little bit here. I'm going to use this little bit of an example here, kind of idealized example, but hopefully you'll get the idea of what we're trying to get at here. So what you're looking at here on the right, and I'll try to explain what you're seeing here, is what you're seeing here is a kind of a probabilistic curve here of temperatures for a particular day. So this is the probability that the temperature on let's say it's today, is what it's gonna be. So in this case, it's the best chance, the highest probability is the temperature is going to be 95 degrees. So that's the highest point on this curve. But there's some chance that the temperature is going to get up to 100. There's some chance the temperature is only going to get to 90 here. But the highest probability is that the temperature is going to be 95 degrees on this day. So this is a probability distribution of the temperatures for say this afternoon. All right, so we can't be certain the temperature is going to be 95 degrees, but this is the probability. So all right, so we've got an emergency manager that's saying, okay, I need to open a cooling center today if the high is 90 degrees or greater. So this must be an emergency manager in Maine or something like that. Certainly probably not in Florida, but somewhere up in the north. Okay. So, if we know what our probability curve kind of looks like, so we've got to, we kind of know what our probabilities are for our temperature today. We can kind of help answer this question. Okay. For today, the probability is the chances are it's definitely going to get above 90. Okay, it's most likely going to be 95, but it's almost certainly going to be above 90 degrees today because the bulk of this curve, okay, is above 90. There's a very little chance that it's going to be down here below 90. Okay, so what we can message him is basically today is this most likely thing here. We can pretty much tell this emergency manager that, yeah, temperature is going to be 95 degrees today, and you're not going to have to worry about being anything different. Because if it's 93 degrees, that's fine. If it's 97 degrees, that's fine, because it's still going to be above 90 degrees, and he still will have made his correct decision of opening that cooling center. So that deterministic message is fine, but we still used our probabilistic information there. All right, so let's look at a slightly different scenario, but with the same forecast. Okay, this is the same forecast for today. All right, it's still highest probability that we're going to have our high temperature today is going to be 95 degrees. Okay, all right, but in this case here, so we're probably back in farther south, back in Florida now. So our EM today, he's got to open that cooling center if the high is going to be 100 degrees or greater. All right, so that's our line right here at 100 degrees. So you can see, so our highest probability is that temperature is going to be 95. Okay. But there is some probability, okay, that the temperature could get above 100 degrees. That's this area under here, above this here. So there's some probability that it's going to be above 100 degrees. Okay, so we want to let him know that there's some probability that's going to occur. All right, so there's a reasonable probability that his threshold might be met, even though we're not specifically forecasting that. All right, so we may want to message him that, yeah, most likely going to be 95 degrees, but there's a chance that it could be higher than that. So we might send this information to our emergency manager. So the highs should be around 95 degrees, but there's about a 15% chance that it's going to get to 100 degrees or so. So that gets that information out there to them. So that's where this probabilistic information could come into effect. Now here's scenario number 3, which is a little bit different, even a little bit trickier. So now same temperature curve again. So our same forecast is basically the same. Our highest probability for temperature is 95 degrees. But now he's got to open that cooling center if the high is 95 or greater. All right. So still expecting the high to get to 95, but there's a pretty good chance. All right. There's this whole area under here where it doesn't get to 95. Okay. And now as the EM, as emergency manager, you do have a cost with opening that cooling center if it doesn't get to 95. So maybe we want to at least let him know that that maybe, you know, there's a chance it's not going to get that warm as well. So we could at least give him the information and say, hey, you know, the highs should be around 95 or more, but there's still, you know, there's a fair chance it's not going to quite get that high. So we're going to pass that information along as well. So we're gonna that's where some of that probability information can come in. So what goes into a probabilistic forecast? So how are those probabilities created? Well, it depends, and it depends on what kind of forecast we're looking at, because they get created in some different ways. And we'll look at some of this a little bit more detail here in a little bit, how some of these get created. But here's just going to give you a couple examples. So these are our wind speed probabilities for our tropical systems. Okay, so you've probably seen these. So this is from Hurricane Michael from several years ago. All right, so these probabilities are created from a combination of the forecast track and intensity of the storm, but it also takes into account climatology, and it also takes into account past forecast track errors. Okay, so there's a little bit of all this kind of mixed in there. So climatology is how storms have typically behaved in the past. The past forecast errors is kind of an average error of things that have happened in the past. And so they basically take the initial point of the storm, and they create these about 1,000 different possible tracks of the storm based on these factors here, and that's how they create these probabilities. So that's one possibility there. So that's the wind speed probabilities from the Hurricane Center. So that's one type of probabilistic forecast there. So here's another type of probabilistic forecast here. So this is some rainfall probabilities here. So this takes, in this case, it's basically 10 different computer simulations of rainfall from 10 different computer models there. This 11th one's just a combination of the other 10. But this is 10 different computer simulations here of the same day, and how much rainfall each of these computer simulations made. So that's just 10 different things. And then you can do statistics based on those 10 different ones. And so you can create probabilistic information on that. So here's 3 examples over here on the right. So you've got an average there. So that's just basically the average. And then you can do percentiles from that. So this is the 90th percentile rainfall there. So that's like a high-end rainfall. We'll talk about that here in just a minute. So it's the 90th percentile. And then you can create things like a probability of more than 3 inches of rainfall. So you can generate thresholds, and this can be especially useful for our partners if they've got specific thresholds of things. So if there is a specific threshold of wind that causes a problem, we can generate. So this is your probability that you're going to get more than, say, 35 mile per hour of wind or something like that. All right, so you can do that. So that's another way to calculate the probabilities there. All right, and then here's another way that the probabilistic forecasts are created. And you may not even realize that these are probabilistic forecasts. So this is the tropical weather outlook from the Hurricane Center, and this is the this is severe weather outlook from the Storm Prediction Center. And both of these are probabilistic products. So these are both based on probabilities. And these are created from model input, so from computer model input, but also from forecaster input as well. And then these are validated and verified from lots of years of forecast. And so these are quite quite accurate over a long period of time. Okay, so this is from this morning actually. So this is your yellow area here for later in the weeks. 20% chance of something developing later on in the week. So that's 20% there. So again, a probabilistic product there. This is not current here. This is from several years ago here, where we've got higher probabilities of tornado development there. So these are probabilistic products there based on these inputs there. All right, so again, so different ways of generating these probabilistic products. So some of the things you might see, some things that we might use in our webinars that you might see, some of the probabilistic products you might see. So one is we use percentiles sometimes. Some might see a most likely, which is typically a 50th percentile. So that means that basically half the solutions are higher, half the solutions are lower. This is the middle, basically. Okay, so that's the median. This is typically going to be close to the deterministic forecast. So it's basically like that 95 degrees that I showed you earlier. So it's going to be, pretty much what's the most likely scenario going to be. Typically close to the average, but not always the average, but pretty much close to the average. So that's the 50th percentile is kind of most likely right in the middle. Like I said, we might have a probability of exceedance. So this would be like a probability that we get more than 3 inches of rain. So that can be useful for heavy rain scenarios. Where we have a threshold, especially if we get a threshold from a partner where they're really concerned about certain amounts of rainfall, or we use this in terms of when we have flash flood guidance. So if we know areas are susceptible for if they get more than say 2.5 inches of rain, or more than 4 inches of rain, or something like that, we can look at probabilities that they're going to get more than that much rain, and that's really helpful. We use this in the wintertime where we look at probabilities for less than 32 inches of rain, or 32 degrees, sorry, 32 inches of rain would be a lot. But less than 32 degrees, so we're looking for freezes or hard freezes or anything like that, those kinds of things. So in tropical operations, we'll use reasonable worst case quite a bit, because a lot of times for tropical especially, we're a lot of times planning for the worst case scenario. That's what we want to prepare for. In terms of tropical, is kind of plan for the worst, hope for the best, but plan for the worst for tropical. So general, we're talking about reasonable worst case scenario, we're looking at the 90th percentile. And the 90th percentile means that 90% of the solutions are below the value, and only 10% of the solutions are above the value. So in this case, we're looking at rainfall in this picture here. So this is the 90th percentile. And so you see these really high values, say around Hattiesburg here. So that means that, this is kind of a reasonable worst case scenario where you're going to get, this high amount of rain around Hattiesburg. So that's kind of what you could kind of plan for as your kind of reasonable worst case scenario. Could be worse than that, but it's unlikely that it would be worse than that. So that's kind of what we think of in terms of reasonable worst case. Occasionally we'll use a reasonable low end, which is the 10th percentile. Typically this is going to be mainly used for like low temperatures in the wintertime. We're looking at, okay, what's reasonably the lowest temperature we could get in a scenario, and that's generally going to be used mainly just for low temperatures in the wintertime. All right, and I think that covers probabilities, at least really quick and dirty for probabilities. So I'm going to ask again, see if there are any questions, see if I've confused anybody. May have confused you more than you even know what questions to ask. But any questions on anything I've covered so far? All right, feel free to put any questions you have in the chat. If you don't want to say them out loud, that's fine. And I think we're going to stop here and take a break here for about 10 minutes. So I think we're going to be back at 10:25. I believe that's right. And then we'll start back at 10:25, and Mark will be starting back up with tropical products. All right, so we'll be back at 10:25.
All right, Mark, go ahead and stop sharing, and I'll put the break slide up.
All right.
People know. You didn't shoot too far overhead. All right, folks, looks like break time is up. So I will stop sharing this and queue up our next presentation that I'll be delivering to you. And this is going to be a deeper dive on tropical products. So hopefully that will, see. Okay, so you should now be able to see the opening slide. That's not the case. Put something in the chat. So for the next 45, 50 minutes or so, we're going to be talking about products that you're going to be seeing coming out over the course of hurricane season. Of course, we are a month into. I don't believe we have to go over this again. I think, yeah, Parks covered that. So the official hurricane season started on June 1st and runs through November 30th. So the chart I'm showing here shows all of the instances where on any given day of the hurricane season, you know, how many years was there a tropical storm or a hurricane out there somewhere in the tropical Atlantic basin? So as you can see, there are instances of these things developing pre-season and post. A little more likely in the pre-season. In fact, a few years ago, we went through like a 7 or 8 year stretch where we had a May system or earlier. It's been a few years since then. So as you see, typically in the month of June, we do not tend to see a lot of activity overall across the Atlantic basin. But if we're going to see anything, it's usually in our neck of the woods. We'll talk about that in a little bit. In July, activity ramps up a little bit, but not necessarily locally. And then we see a big ramp up in activity. Hold on a second. Hold on just a second, folks, while we swap this presentation out for the latest. Hold on. All right, sorry for that. We got the correct presentation up here now that these things happen when you're doing collaboration like Parks and I are. So, we're a month into the hurricane season, and, we may see something later in the week. It's a little uncertain now, but you really start to see things ramp up in August, peaking in September, and still pretty busy, at least, the early parts of October. And then it's pretty rare to see anything in November, north or South Florida. So we'll move on here. Now, the areas that you need to be paying attention to do vary as the season progresses. So in early season, May, June, most typically you will find development close into the United States. So we're talking about the Gulf of Mexico. Like the entire Gulf is in play. We've already had a Gulf system ferry off in the Bay of Campeche there in the southwestern Gulf of America, and off the southeast U.S. coast. So oftentimes you'll see a decaying cold front that manages to push this far southeast, and then maybe something spins up on that. So that's June climatology. We get a June system affect us about every other year, but not this year. So July, if you look in real close to most of our forecast area, is kind of in the lower probability of any kind of impacts in the month of July. So usually July is not that active. But as you can see in August, there's a lot higher chances of development, really all across the tropical Atlantic basin. and along the U.S. East Coast, Gulf of Mexico, all that. September's the peak. You're going to see systems, thunderstorm complexes come off the west coast of Africa, and some of them organized very quickly into tropical storms. Over there near the Cape Verde Islands, you'll sometimes hear them referred to as Cape Verde storms. So unlike June systems that can develop right near the coast and give you very little time to ramp up, right, preparedness, these Cape Verde systems, you see them coming for 7 to 10 days, but that gives them a lot more time to strengthen, right, become big, strong hurricanes. In October, we tend to lose the African activity there, but we still have decent chances for development in the Gulf, the Caribbean, and off the southeast U.S. coast. And then in November, typically things drop off quite a bit. We do occasionally get a November hurricane in Florida. So let's talk about some definitions. If the National Hurricane Center identifies an area of low pressure, closed circulation, winds are rotating all the way around counterclockwise, but it's not all that windy yet. In other words, sustained winds are less than 39 miles an hour, but it is an organized area of tropical low pressure. The Hurricane Center can call that a tropical depression. And those are numbered sequentially through the season. So the first one that forms is Tropical Depression 1, the second one, Tropical Depression 2, and so on. Now, once one of these systems achieves maximum sustained winds of 39 miles an hour up to 73, it is named and becomes a tropical storm. If winds continue to strengthen up to 74 miles an hour, that's the lower threshold for hurricane. So then it will be upgraded to hurricane status. And then you see on the chart below the Saffir-Simpson wind scale, which categorizes hurricane strengths into 5 categories. So category 1 are 74 to 95 mile an hour sustained winds. So as a point of reference, last year's Debbie was a category 1. In 2016, Hermine was a category 1. In terms of category 4, that was Helene last year. And category 5, that was Michael over in Panama City and Mexico Beach, really devastating hurricane over there. All right. Watches and warnings. These are often confused. I mean, they're kind of similar words, and so typically, unless you get a system that develops right off the U.S. coast and there's not enough time for the watch phase, typically the watch will be issued 48 hours ahead of the anticipated onset of tropical storm force winds. And even if we're forecasting a hurricane, the watch issuance is timed to the onset of tropical storm force winds, because that's, once you reach winds of that speed, it starts to become dangerous to be out and about, continuing to prepare or evacuate. Causeways get closed down at that speed typically. So if you haven't evacuated by that time, you may not be able to, right? And also, first responders typically cease operations a little bit higher than 39, I think about 45 miles an hour. So you will no longer be able to get a response from a 911 call in most cases once winds reach tropical storm force. And therefore, you need to be in the hunker down phase and self-sufficient at that point. The warnings will come out 12 hours later or 36 hours ahead of the expected onset of tropical storm force winds. Now, storm surge watches and warnings follow the same paradigm, really. The watch comes out 48 hours ahead of the possibility of life-threatening inundation. So enough surge to create a threat to life. And it doesn't take a lot of surging water to be life-threatening. Think of children. That's you're not going to be able to drive through surging water very easily, even without that much depth. So it's really, really important if you are tuning in from a coastal county or have interests there, family, friends, whatever. Evacuation orders are typically based on storm surge, the mandatory evacuations, and it's extremely important to heed those because storm surge is the biggest killer in hurricanes and tropical storms. So the warning will come out 12 hours later. All right, this is a review of the 2024 season. And it was an above average season. There were 18 named storms. And one thing you'll quickly notice is just how busy it was in the Gulf of America. There were 5 landfalling hurricanes in the Gulf. One over Texas, Louisiana had one. And for Florida here, we had 3 landfalling hurricanes, and a couple of them were doozies. You know, you had Helene and Milton there, and Debbie as well. All right, and Debbie and Helene impacted Georgia pretty significantly as well. So moving on. So we've already had 2 named systems develop this season, Andrea and Barry. Andrea was way out at sea, not really impactful. Barry developed down in the southwest Gulf and has already moved inland and is no longer a factor. So the next name on the list is Chantal. Now, there's a lot of numbers in this chart here. Basically focus on that, the first row of numbers. That's what is considered average or normal season. 14 named storms, 7 hurricanes, and 3 majors. But we've had quite a long run now of getting above normal seasons for the most part. And you can see various entities in academia and the private sector, their predictions for the season. And then on the far right, you see NOAA, our parent agency's official forecast that was issued in late May, calling for 13 to 19 named systems, 6 to 10 hurricanes, and 3 to 5 majors. So there, in that envelope of ranges there, you can see there's a possibility for a near normal season, but it's definitely favoring above normal. I get the slide to advance. So this breaks down this way. There's a 60% chance that we'll have an above normal season. But, you know, still a 30% chance we could be near normal. So very unlikely that we'll have below normal activity. So now I'm going to get you oriented to how you can find information on the web if you want to stay abreast and situationally aware. And one good place to start is our locally focused tropical webpage. Now, don't get me wrong, the National Hurricane Center at hurricanes.gov has plenty of great information. But this page here is tailored to focus on our local area and impacts. And so therefore, we kind of recommend it. And the other neat thing about this page is every office that has any potential for landfalling tropical system from Maine to Texas and even Southern California has web pages laid out exactly this way. So if you learn how to navigate your local page and you find yourself somewhere else when there's a threat, you'll be able to navigate that local page as well. So how do you get to this page? You go onto our weather.gov/TAE, but weather.gov/Tallahassee also works. Okay, that's easy to remember. And then you hover over this forecast menu there, above the map, and select tropical. And you'll get this page that I'm showing on the right with various types of things. Then the default front page will be the outlook, which I'm going to talk about here in the next couple of slides. And then there will be specific tabs for any active system. You don't see one in that example because that tab doesn't appear unless there is an active system out there somewhere. And then you'll have threats and impacts for that associated system. If there's more than one system, then all of that will also appear on this page. You can see the links to satellite, radar, social media, and general preparedness links as well. So it's meant to be a one-stop shop. And I encourage you to check it out this season and maybe bookmark it. So what is typically included in what we in the biz call an advisory package? All right, so every 6 times, a day, the National Hurricane Center will put out a new advisory. And with that new advisory, you're going to get a whole bunch of new and updated graphics, including the cone of uncertainty, the latest changes to watches and warnings, both at the coast and inland, updated storm surge forecasts, updated wind speed probabilities, updated time of arrival graphics, which we'll be discussing these in a little bit. So all sorts of new information will become available. after these advisories. So let's start doing a deeper dive on some of these individual products. The first I want to talk about is the tropical weather outlook. Parks briefly touched on this, but this is an outlook that starting on May 15th and continuing for the rest of the season are issued routinely 4 times a day at 2 a.m. and 2 p.m., 8 a.m. and 8 p.m. These are Eastern time. Now, if something develops or some significant change happens in between those times, the Hurricane Center can always issue a special tropical weather outlook. So this is a combination of text and graphics that kind of is a great situational awareness tool so that you don't get caught by surprise. So let's take a look at what you're going to find in that. So here's the text portion where it kind of describes the area. Hold on, I get somebody. Describes the area of interest and the potential scenario of what's going to happen. And then at the bottom, you're going to see the likelihood of development over the next 2 days or the next 7 days. This is an example of a unscheduled off-time special outlook that's issued for maybe in this case, Hurricane Hunter aircraft went through and found something significant that needed to be reported. And there you go. That's another example of that. They'll also sometimes mention whether, the possibility of watches and estimated potential time that those might come out. All right. So this is a look at the 2-day tropical weather outlook. And on this, it's going to be overlaid on a recent satellite photo. And any existing systems, like in this case, you see Franklin there, Tropical Storm Franklin, will be on this. And then there may be X's. X marks the spot of areas of interest that have caught the National Hurricane Center's eye that they determine have at least some chance of becoming tropical cyclones. And tropical cyclone is just an umbrella term for depressions, storms, and hurricanes, and typhoons. And I think in Australia they're called willy willies. But anyway, this is a great graphic to kind of draw your attention. I see that area down in the Caribbean Sea. Maybe we should pay attention to that. Now, the 7-day tropical weather outlook, I think, is even more useful. It's going to show the current systems and the X's, but it's also going to show a hatched area for each of those potential areas of development. And they're color-coded, right, in terms of the likelihood of development. So you see that the yellow ones are less likely for development, less than 40%. Kind of the average chance of development, or 40 to 60%, is the orange, and the reds are where there's likely development there. So in this case, pretty high confidence the Hurricane Center had that something in the Northwest Caribbean Sea would develop somewhere in the Northwest Caribbean or the Eastern Gulf of Mexico. Now, it's important to make the distinction that these are not like the cone. These are not impact areas or forecast tracks or anything. They're simply areas for initial development. So it's important I recommend that to our partners to at least take a look at this once a day. Bookmark it and keep an eye on. So you know if something is potentially coming. So I've already kind of covered this. The color coding does not imply potential magnitude. Okay, it has nothing to do with the potential strength of the system because they haven't really even put a forecast out for it yet because it really hasn't developed yet. So it's important to keep that. It's not an indication of impact or forecast track. So here's an example of the 7-day outlook. And in this particular case, you've got an X over the Florida Keys with a potential system moving towards the west. And in this case, there's an arrow because it's not expected to develop, at least until it reaches that orange hatched area. So not until it reaches the Central Gulf. So that's important information to know, right? So moving on, let's talk about the cone of uncertainty. Before I do that, Parks did show you today's tropical weather outlook with that low chance 20% of development, either in the Northeast Gulf or off the Southeast U.S. coast. Right now, it could be either or. If a system develops off to the east of Florida, it's going to have minimal impacts to us. You know, a Gulf side development, yeah, certainly some chance for, you know, local impacts, most likely probably heavy rain, but it's really too early to tell. We'll be keeping a close eye on that for this weekend, particularly since it's a holiday weekend. So keep an eye for that. So let's talk about the cone of uncertainty for a few slides now, because this is quite often misinterpreted. So I'm going to try to hammer home here. If you take one thing away from today's training, is that the cone is a probable track of the center of the system. All right. It has nothing to do with impacts. So impacts can and do occur well outside the cone. And how is this cone of uncertainty created? Well, the Hurricane Center takes a look at their forecast track areas over the last 5 years. And there's a certain radius for those areas, right? And then they apply those at the various forecast steps, 12 hours, 24 hours, 36 hours. So there's, imagine a series of circles here. And then they just kind of combine the circles and come up with this cone. So remember, this is a 2/3 of the time the track will stay in the cone. This comes as a surprise to some people. So 1/3 of the time, the center of the storm will be outside the cone, much less the impacts. So on this cone page, you're going to see coastal watches and warnings as depicted here in the red, blue, and yellow. And then you're going to see letters, you know, for the various forecast points. A D means the system is expected to be a depression strength, was less than 39 miles an hour at that point. And S stands for tropical storm, and then H is hurricane, and is major. So in this case, for Irma, for back in 2017, it was a major hurricane and was forecast to continue to be one all the way east at this point. So the forecast cone is not an indication of the areal extent of the tropical cyclone impacts. And we'll use Irma again. The light orange shade is the forecast extent of tropical storm force winds. And you can see how far outside the cone those extend. In fact, we've got tropical storm warnings all the way up into South Carolina for a system that was forecast to track up the west coast of Florida. So yes, impacts extend well outside the cone. Here's another example. Imagine that that white line is the cone, and it's overlaid on the wind speed probabilities. Okay? And wind speed probabilities are an indication of the likelihood that tropical storm or hurricane, depending on which chart you're looking at, conditions will occur at any given point. So they're not regional forecasts. So we can't say the west coast of Florida has an 80% chance of tropical storm force winds. So individual locations in that dark red area have an 80% chance. So the overall likelihood of tropical storm force winds along the west coast of Florida is going to be higher than that. Okay, and that can be a little confusing, but keep in mind if you're focusing on one particular, like your school district, then the chances of tropical storm force winds occurring in your district will be based on the color coding here. Okay, so this is a probabilistic forecast that Parks mentioned, and I think you probably remember the animation. These are calculated based on 1,000 different possible reasonable forecasts, right? And out of the 1,000, let's say 600 of those solutions bring tropical storm force winds to any given location. Well, then that means 600 over 1,000, 60% chance of tropical storm force winds, and that's how it's color coded on the map. The forecast cone graphic should not be used to anticipate the onset time of impacts either. I'm going to show you what you should be looking at. And by the way, if you'd like a deeper dive into the cone uncertainty, a couple of forecast hurricane specialists down at the National Hurricane Center have recorded a video tutorial on this that you can get to by scanning that QR code. So that is available. You can scan it right now, or when we provide the slides and recording later, you can get it there. All right. And I already talked about this. It's based on the average track error over the last 5 years using the 67th percentile. So, and then these little circles. So the forecast track accuracy from the Hurricane Center is super, super good, right? In the early stages, like 12, 24, 36-hour forecast. But as you would expect, the average errors increase out in time, right? So the 5-day circle is a lot bigger than the 12-hour circle. And then they just connect those circles, and that's how you get the cone. So another important thing to consider about the cone, since these are based on average forecast track error, that cone is going to be the same width all season, no matter how strong the hurricane is predicted to be or how weak, no matter how large in size it's expected to be, no matter how much uncertainty or certainty there is in the forecast. You're going to get the same size cone. So keep that in mind. So because there are all these potential ways to misinterpret the cone, the National Hurricane Center introduced this alternative cone graphic midway through last season. This is an example for Hurricane Helene, where the cone is basically overlaid by the current watches and warnings. And it's not just the coastal ones. All of the inland ones are highlighted here too. And that's to drive home the point that, by the time there's warnings out, you really shouldn't be paying attention to the cone at all. So in this case for Helene, there was a tropical storm or hurricane warnings up for the entirety of the state of Florida, and at least watches and warnings for the entire state of Georgia, and all the way up to North Carolina. Now, the little hatched area you see there means there's a tropical storm warning and a hurricane watch in effect at the same time. Now, you see in this case that the Central Florida Peninsula has a tropical storm warning, crosshatched in blue, and a hurricane watch in pink. This year, we are introducing zoomed in, localized versions of this product. So it'll be easier to pick out, where you are in terms of the warnings and what have you. Parks Camp, local student here that's been helping me out with this training, created these. So these are going to be available this year for the first time. Make it easier to see that. All right, here's an example again from Helene, showing detailed which counties are in a warning, which are in a watch, which are in a hurricane watch warning, which are in tropical storm watch warning. And as you can see, a good chunk of our forecast area at this particular advisory time, with a major hurricane forecast to make landfall right at the apex of the Appalachian Bay, moving at a fast speed. Really one of the worst case scenarios there. And here's another zoomed in shot. And even closer. So there's various scales here. So as we get closer into time, the orange area, again, let me remind you, shows the current extent of tropical storm force wind. And the brown area, the current extent of hurricane force wind. All right, wind speed probabilities. I mentioned this a little bit in the preview earlier. These are location-specific probabilities of tropical storm, strong tropical storm, or hurricane force winds. So all three are available. And I explained to you how they were developed by using these 1,000 simulations. So here's an example of 1,000 different forecast tracks. And in this case, 400 of them indicated, if 400 of them are indicated tropical storm force conditions occurring at any given location, then that location has a 40% chance of getting tropical storm force winds. And another thing I wanted to say about this before I advance, is in this case, we are taking forecast uncertainty into account, unlike the cone, right? So if all of these solutions are very well clustered, you're going to see a narrower field of wind speed probabilities. If they're all over the place, it's going to be a big broad area of wind speed probabilities. And that's an important piece of information to have. So again, track uncertainty makes a big difference. You know, in the image on the left, you see the various hurricane forecast models kind of all over the place about what's going to happen with this given system. Some recurve early up across the peninsula, some do so in the eastern Gulf, others just keep on trucking along off to the west. So you would expect a broader area of wind speed probabilities here. However, the Dorian here on the right, it devastated the northern Bahamas, was a category hurricane that basically stalled for a day or maybe more. But it was accurately predicted to do that, to stall, not to come ashore to Florida, and instead turn north. And there was a high degree of agreement in the track forecast here. So, you know, the confidence in the forecast is higher, and the wind speed probabilities would probably have been narrower there. Now, there is a text product for wind speed probabilities, and I'm going to take some time to explain to you in case you come across it. You see the various forecast hours there at the top, the 12-hour forecast, the 24-hour forecast, 36, and so on. And then you see for each city listed there, you see the probabilities of the various wind speed thresholds. 34 knots or 39 miles an hour for tropical storm, 64 knots or 74 miles an hour for hurricane. And X means there's negligible probabilities for that forecast time. So let's just take, let's say Tallahassee. Why not? You can see it's not until the 48-hour time stamp here that there's any probability of experiencing tropical storm force conditions. And then at the 72-hour point, you see a 28% chance. So by the time you get to 72 hours, if you add those two up, 28 and 2, you get a 30% chance that by 72 hours, you will have received tropical storm force. You also see that that 28 is the highest number. So that's the most likely time of arrival, right? I will caution you, though, that these don't always 100% agree with the graphics, and we recommend that you rely on the graphics. So let's look at this case. Let's see, what do we have in here? Tallahassee's kind of in the brown to orange, like roughly 60%, right? Maybe 50. So you see the overall threat of tropical storm force winds there. The cumulative threat is 47%. The highest time period there you see is 18% at 96 hours. So that's an example there. Tampa, it's much higher, 86%. So you see that in the higher, the redder color, and so on. And again, these similar graphics are available for what we consider strong tropical storms. It's 50 knot or 58 mile an hour wind speeds, and hurricanes, 64 knot or 74 miles an hour. Now, it's important to keep an eye on trends. Not individual necessarily changes from one advisory to the next, because there are going to be instances that happen in almost every tropical system where there'll be sort of an artificial dip in the probabilities because of how they're calculated. It makes a difference whether the closest forecast point to the coastline is inland or still offshore. So that's why we say focus on the trend. If it's been up, and then all of a sudden down, but the forecast track really hadn't changed much, and the system strength hasn't changed much, then don't be fooled by that. And we'll point that out in our briefings very clearly. But trends are important. If you're seeing up, well, that should be a confidence booster that they're actually going to be those impacts. Now, frequently overlaid on top of the wind speed probabilities are the estimated time of arrival. And these are probabilistic forecasts. And there are two types. You heard Parks talk about the reasonable worst case scenario. So this is the equivalent in terms of timing. And we call it the earliest reasonable time of arrival for tropical storm force winds. This is based on the 10% exceedance. In other words, there's only a 10% chance that the winds will arrive before this time. So we consider it still safe to be out and about preparing, doing last minute preparations up until the time listed on as early as reasonable. arrival time. 90% of the time, the winds will arrive later than this. So in the case of the western Florida Big Bend and far southwest Georgia, that time of arrival is earliest reasonable is 8 p.m. on Tuesday. Now, the other kind of graphic will be called the most likely time of arrival. And in this case, 50% of solutions are slower in bringing the winds in, and 50% are faster. So at this point, it is no longer considered safe to be out and about trying to evacuate or getting last minute things from the store, or showing up at home or anything like that. So really, we want you to be completely done with all preparations or evacuations or whatever, and hunkering down by this time. So in this case, for that same area I mentioned before, instead of 8 p.m. on a Tuesday, it looks like it's more middle of the night, Tuesday night, and most likely arrival time. So let's compare the two again. In this case, it's a forecast for tropical storm for Ian, who of course went on to become a hurricane and devastating impacts in Southwest Florida. But in this particular advisory, when it was still aiming right here to Tallahassee, the earliest reasonable arrival time at the Florida coastline of the Panhandle Big Bend was 8 a.m. Wednesday, but the most likely time was 8 p.m. Wednesday, so 12 hours later. So again, and to summarize, wind speed probabilities are location-specific probabilities that reflect uncertainties with each storm. They incorporate uncertainty and forecast track size and speed, and probabilistic forecasts really give you a better range of possibilities. So let's talk about watches and warnings now. Again, as I mentioned earlier, watches will come out first, then the warnings. And starting last year, the Hurricane Center changed its policy, and they now have the option to introduce watches and warnings on the intermediate advisories. So, when the system's getting closer to land impact in the United States, they will increase the frequency of advisories from every 6 hours to every 3 hours. So, one of the main motivations for doing this is it gives them an option to not issue initial watches or warnings at 5 a.m., right? And the warnings, they're going to set off your phones. I mean, they're going to alert you up. And rather than waking everybody up at 5, they can hold off till 8, okay? And then issue the initial watches and warnings. Something new this season, is that there are instances where a depression hasn't formed yet or a storm, but there's a high degree of confidence that a storm will develop and impact land areas within the next 72 hours. Now, in the past, so in other words, they can initiate entire forecast packages for a system that hasn't been named yet, right? Or isn't even a depression. So this year, we're going to have an extra 24 hours of potential notice with the full advisory package. So that's a great increase in service from the National Hurricane Center. So, watches and warnings. They're issued, some are issued by the Hurricane Center, some by your local office. So here's an example from Tropical Storm Fred from back in 2021 of what the Hurricane Center issues. They issue only for the immediate coastline. So in this case, they have tropical storm warnings from basically St. Mark's west, to cover the western Big Bend and parts of the Florida Panhandle, right? Watches further west. And then when they, through collaboration with us, make those determinations, we, the local office, then decide what parts of the marine area, how much of our Gulf of Mexico forecast area needs to be under a watch or warning, and how many inland counties need to be put in a watch or warning. So in this case, you can see we decided to put tropical storm warnings up all the way to the Alabama line, and watches for those 5 Alabama counties just for timing reasons. It's just going to be longer time before this impacts reached that level. All right. So watches and warnings are based on based on probabilistic information, not deterministic. And that might explain what you see there on the left. You see the deterministic forecast, the most likely forecast with the cone. Now, the track center line coming up in the Florida Panhandle. But watches are up all the way to the apex of the Appalachian Bay. But if you looked at the probabilistic forecast, you can see that the wind speed probabilities extended much further to the east than the cone indicated. And so the eastern extent of the warnings were based on that. And I think I already mentioned this earlier, that, this year, it began mid-season last year, but this year again, we're going to have that option about 10, 15 minutes after the initial cone comes out. You'll see this version of it with all of the coastal and inland extended warnings overlaid on it. Storm surge. There'll be watches or warnings, and these are collaborated between the storm surge unit at the Hurricane Center and the local office. Not only the extent along the coast, the aerial extent, but how far inland we need to have storage support. Okay, so any area in this pink here, we're expecting enough storm surge to be deadly. Storm surge of significant depth to be a significant threat to life. So if you're in the pink area, you really should have been planning evacuation. So before I wrap up the tropical year, I did want to advertise, and please take an opportunity to scan that QR code. For the second year now, this could be an annual thing, we're planning a series of public-oriented tropical training. We've for many years done training for partners like y'all and emergency management media, but this is intended for the general public. And each day you see here, starting on Monday the 21st and going through Thursday the 24th of July, we're going to have 3 webinars each day on the same topic. One late morning, one early afternoon, and one evening. Registration's free. And we'll start off talking about early or preseason readiness. On day 2, we'll go to, all right, there's a system out there. What do I need to be doing now? Now that there's a system out there and we have more information. And then the third day is how to stay safe during the impact phase. When basically, the winds and rain and all the other threats are happening. The do's and don'ts, right? And then we wrap it up on day 4 with how to stay safe after. It's a shame that so many people lose their lives after the system has passed because of various reasons: electrocution, carbon monoxide poisoning, heat stress, and on and on and on. So we'll be discussing that in depth. So please, please, please share this information widely. Okay. So school officials on this call, share it with the parents, your email list to the parents. Emergency managers and others on this call, you've already seen this, but please continue to share this information, and we'll be putting out more advertising as we get closer to the event in late July. So at that point, I will stop and see if y'all have any questions right now before we take our next break. All righty. So I don't see any questions. So come back by 11:20, and I'll be back with you to talk about severe weather, severe thunderstorm watches, tornadoes, excessive rainfall, timing, and important things like that that you need to know to make an informed decision. So for now, I will go ahead and say be back here at 11:20. update the brake graphic here. Okay. All right, see you back in 10 minutes. Alrighty, break time's over. I'll go ahead and stop sharing that slide and queue up the next training session. All right. Now we're going to switch gears and talk about severe weather. And by severe weather, we're referring to severe thunderstorms and tornadoes. All right. So, or at least for those folks on here from school districts, understand that a lot of your key decision thresholds are based on whether you're going to have to use your schools for shelters, right? So some of that is really not, as I understand it, necessarily a decision that is made, entirely by the superintendent, right? So, but severe weather is, and I understand there's probably varying levels of coordination between county emergency management and school districts. I know here in Leon County, it's the school district largely operates independently in terms of making these decisions. And they participate in the webinars we offer by going over to the county EOC. And, that really is a recommendation for y'all, or to send at least some representative, the superintendent, or one of the safety officials from your district to the County Emergency Operations Center when it's activated to get in on these webinars. Okay, so I'm hoping that we're going to clear up some potential misunderstandings or clarify some of what these actual products that come out from the Storm Prediction Center and your local office, what they actually mean and what they don't mean. So we're going to start out with Storm Prediction Center products, the products that are issued by the National Center, excuse me, out in Norman, Oklahoma. Then we'll spend a little bit of time, although Parks covered this briefly, on the climatology or return frequency of some of the various risk levels from the Storm Prediction Center. We'll spend a little time discussing timing severe weather systems and the challenges associated with that. We'll follow that up with some recent changes we've made to our timing graphics to hopefully give additional information that we're hoping will help in the decision making, right? Which is generally going to be the most significant decisions to be made are whether to close school for the day, to delay school, either arrivals or departures, all of these things. And then we'll wrap up with discussing the excessive rainfall outlooks that are issued by the Weather Prediction Center. So let's start with Storm Prediction Center products. So the Storm Prediction Center issues outlooks, daily outlooks, up to 8 days out in time. And they use a 6-tiered system to rank the probability of severe thunderstorms and or tornadoes or large hail. And so an example on the right there shows, one of those rare days that there's a high risk, so the highest level. But the light shade of green on here indicates that thunderstorms are expected, but not expected to reach severe limits, resulting in watches and warnings. The marginal risk is in the darker green. All right. Pretty common. We get a bunch of those every year. The slight risk, yellow, it's really a poorly named risk. Slight is significant in this context. Most slight risk days, you're going to get a watch at some point. Severe thunderstorm or tornado watch. Now, as Parks had already mentioned, the return frequency of an enhanced risk day is much, much longer. In other words, this is a much rarer event. And I understand that a lot of the decision thresholds, that this is a decision threshold for some school districts. And then there's even the more rare, moderate risk and high risk that you see indicated in the red. and the pink. Now, the Storm Prediction Center also issues the watches. So the tornado watch, severe thunderstorm watch. There's always a collaboration call with the local offices impacted to discuss the aerial extent and things like that. So this is a collaborative effort, but the actual watch product is issued by the Storm Prediction Center. And then it's your local office, like the one here in Tallahassee, that will do the warnings. So the tornado warnings, severe thunderstorm warnings, flash flood warnings, and so on. So the outlook, this is a very important thing to remember. You'll hear reference to the day 1 outlook, the day 2 outlook, and so on. So SPC days run from 12Z to 12Z, or 7 a.m. Eastern time to 7 a.m. Eastern time the next morning. So they're actually outlooks for that day and then the following night. Okay, and it's a 24-hour outlook. Sometimes the main threat is going to be during the daytime period. Sometimes it'll be the nighttime period. And that will be explained in the text and in the briefings that we will be doing. So day 1 outlooks are, there's an initial issuance at 1 a.m. Eastern time, and then updates several times later in the day, 8 a.m., 11:30 a.m., 3 p.m., and 8 p.m. Now, the day 2 outlook, which really, when it comes to decision making, is maybe the most important. Their initial release is in the middle of the night, so 2 a.m. Eastern, and there will be an update at 12:30 p.m. Eastern. And typically, no further updates. There are rare occasions where there will be an upgrade, but so that's the day 2 out, and it's kind of similar a paradigm for day 3 outlooks. They're also issued 2 times a day. The initial is at 3:30 in the morning, and then there's an update at 2:30 p.m. And then for the remaining outlook period, days 4 through 8, those are issued just once a day at 5 a.m. All right. Now, in the day 4 through 8 period, it's not a 6-tiered system. It's just 2. So in other words, the equivalent likelihood of a slight risk, yellow, or enhanced risk, orange, are the only things you're going to see on these final, out periods, if you will, the days 4 through 8. And if there are no shaded areas on the map, you'll see one of these 2 options. Either predictability too low, which, as it implies, there's not enough confidence to outline any specific area, but there is potential that some area may have a severe weather threat. It's just the models haven't honed in on a specific solution to give the Storm Prediction Center forecast specialists enough confidence to highlight a particular area. The potential too low is used to indicate that, confidence is high enough to say we're not expecting severe weather. So if you see that, you're probably, in the clear. Predictability too low means, pay attention. By the time you get to day 3, we'll see if maybe there's an marginal risk introduced. There's a lot of words here, but I'm going to walk you through it. These are the 5 main risk areas. You get general thunderstorm, not really a severe weather risk, right? And, typically what you should expect. So let's just go across marginal risk. Basically, and this is a general description, and not all marginal risk days will be the same, but some storms could be capable of damaging winds and hail, implying most will not be. And there could be a localized tornado threat. So on a marginal risk day, most areas will be okay, but some areas will not. And of course, there are certainly going to be marginal risk days that nothing happens. Okay, that's always a possibility. So how bad would the worst storms be? Well, similar to storms your area may experience several times a year. Okay, wind gusts to 58 miles an hour. Well, I'll get to the definitions in a minute. Slight risk means there's an increased confidence that storms will contain damaging winds and hail. So now, instead of just isolated, there could be isolated to scattered severe storms. In other words, storms your area may experience a few times a year. The enhanced risk, there's a high confidence that several storms will contain damaging wind and hail. So scattered to numerous severe storms. And in this case, similar to storms of this intensity, your area may only experience once or twice a year. And then there's the moderate risk. High confidence the storms will be have damaging winds, hail, tornadoes, and that these could be significant. And significant tornado would be considered a category EF2 or higher, and hail, I think 2 inches in diameter or greater. Yep, look it over to the right there. So wind gusts of at least 75 miles an hour. So that's another thing. So that's the definition of significant severe. And then, of course, the high risk days, those are the exceptionally rare outbreak type days that your area may only experience twice in a lifetime. So super, super rare. If you ever find yourself under high risk in our area, you got to be paying attention. It's going to be bad, probably. So let's take a more detailed look at the convective outlook. I want to underscore the point that, when you see a marginal risk area, or roughly a 5% chance of a severe thunderstorm or tornado occurring within 25 miles of any given point. And a slight risk, 15%, right? Enhanced is 30. But the probabilities don't lurch, discontinues like up instantly as you cross those orange lines from slight to enhanced, right? So let's take a look at the Carolinas. Both points A and B are in the slight risk. Point A is much, much closer to the marginal, right? So while the risk is at least 15% in that area, maybe you could see 17%, right? Point B, much closer to the enhanced risk. So just because it's outside the enhanced risk, pretty darn close. So if you're using enhanced risk as a decision point, and you're just outside the enhanced risk area, understand that point B, the probabilities of severe weather are much higher than point A, probably around 28% in this case. And then, of course, also keep in mind the update schedule, right? Now, these things can change. Now, every once in a while, you'll see a hatched area, like indicated here, on an outlook. That's included when there's a 10% chance or greater probability for significant severe, as we define on the other slide, within 25 miles of a location. So in this case, you see the red area there, right, equivalent to, 30% probability of severe weather. Not all of it is hatched. So southeast Georgia, central Georgia, outside the hatching. Areas inside the hatching mean 10% chance or greater of seeing EF2 tornado, sometimes referred to as strong tornadoes, or thunderstorm wind gusts of hurricane force, right? That's 65 knots or 74 miles an hour or greater. Lots of times we struggle with getting people to be reactive to severe thunderstorms, including watches. But if you're in a hatched area, and we're expecting a lot of stronger than normal gusts out of severe thunderstorms, think about it. Hurricane force gusts. They're going to do some damage, even if it's for a brief period of time. And oftentimes, a high-end severe thunderstorm can do a lot more damage than a tornado. Tornadoes can only get so wide, and there'll be a path of destruction, right? But if we're forecasting one of these hatched area severe thunderstorm days, you could see big swaths of wind damage. And then hail also is taken into account in cases where the hail is expected to be 2 inches or larger. And that's going to do some damage to your car windshield and your head, right? If you're out there, then that can qualify for a hatched area too. Another product that the Storm Prediction Center issues is called a mesoscale discussion, or MCD. And this focuses on the severe thunderstorm potential over the next 6 hours, with an emphasis on the first 1 to 3. So these are often going to come out before any watch. And what are you going to find in this product? The text portion of the product will discuss the development and evolution of severe convection in relation to watch potential or within an existing watch. So these will also be issued to provide updates on current watches. Now, let's say watch hasn't been issued yet. There are several tags, if you will, that will be included in this product to indicate, how confident the Storm Prediction Center is that a watch will be issued. And in some cases, it'll say watch unlikely. That's important information to know. Doesn't mean there won't be a watch, but it's unlikely. So there's only a 5 to 20% chance-ish of a watch being issued. Now, oftentimes you'll see severe weather watch possible. So it's roughly a 50-50 chance they're going to see a watch. And then watch likely, if they issue a watch likely tag, it's likely that you're going to see a watch come out eventually. Sometimes they'll add detail and say tornado watch likely. Right? And sometimes, if they're confident that the environment is supportive of tornadoes and that the primary threat is going to be damaging straight line winds, they'll issue a severe thunderstorm watch likely. And then there's the case where the watch is going to be coming out any minute. Watch needed soon. Don't see that very often, but because why waste time with that when you could just start coordinating the actual watch? So these mesoscale discussions are important to keep an eye out for. You'll see them in our tropical news feeds, or you could just go to the Storm Prediction Center website, and it's pretty easy to find these things. So this is an extra heads up. So this is what the text looks like. All right, so you see at the top, first you have the areas affected. So in this case, they're talking about at eastern Alabama, the western Panhandle, western Central Georgia, areas within the blue line. Then you see the probability of watch issuance, in this case, 60%, so likely. And then they get in to a summary of the discussion, and the discussions can be short or they could be more detailed like you see here. And you can get into some technical jargon in here. So, just warning you about that. But the key takeaways from this is the likelihood of a watch issuance. And then, very recently, they've added this really handy stuff at the very, very bottom. At their estimate of the most probable peak tornado intensity. So in this case, they say up to 95 miles an hour, which is EF1 strength tornado. Most probable peak wind gusts, in this case, 55 to 70. So kind of your typical severe thunderstorm, and hail up to 1.25. So in this particular case, you're probably not in a hatched area convective outlook. So here, unfortunately, the graphic I can find, it's discussing the watch there to the east, the one with the dashed lines here. Typically, a SPC watch will cover 20 to 40,000 square miles, and be in effect for 6 to 8 hours. So, if you're in the western part of the watch, you might be getting severe weather very soon, 2 or less hours at a time. Tornado watches, they really make the effort to get the watch out with an initial lead time of 2 hours for the first tornado. Severe thunderstorm watches are issued for the threat of at least 6. So, and again, multiple tornadoes or a threat of a single intense tornado. That'll prompt a tornado watch. If there really isn't much of a threat of tornadoes, so you're dealing with severe thunderstorm, those watches are issued for the threat of at least 6 total severe weather events within the watch box. And they aim for an initial lead time of 45 minutes for that one. and watch status messages of existing watches, discussing, whether the threat continues or if it's waning or increasing or whatever. They're issued at the bottom of the hour, every hour within the watch time frame. So here's an example of the text of a SPC convective watch. In this case, it's a severe thunderstorm watch, and it indicates the general geographical areas in that first bullet. The effective time, it's going to be in effect from 2 p.m. until 9 p.m. Eastern time. What the primary threats are. In this case, they have a tornado true possible as the third bullet. So the implication here is scattered, damaging wind. The straight line one's probably the most likely impact. And then there's a summary. So that's what the text product looks like. Graphically, now, you saw that the Storm Prediction Center draws parallelograms. The weather does not look like a parallelogram, right? So what we do is in a collaboration process with the Prediction Center, and they will do a video chat with us before issuing the watch and to discuss, you want this county in, you want this county out, do you want any part of the Gulf of Mexico included? So in this particular case, they would have had a video conference call with our office, the Mobile office, Birmingham, and that. And let me admit this person. Okay. So, and that's what the watch graphic would look like in social media. Now, once the Storm Prediction Center issues a watch, we will issue a localized version that looks like this text on the left, which breaks down even further, like which specific counties are in this watch, right? And then there's a list of cities as well. Now, we will use this product in collaboration with the Storm Prediction Center to clear counties out of the watch once the severe weather's moved through. And we try to stay on top of this. Probably there's occasions where it might be frustrating that we haven't gotten around it. We're busy sometimes, but we try to stay on top of this. And, once the threat, like if it's a squall line that you can clearly see the threat is over, clearing counties out of the watch before the expiration time. Now, there's a thing called a particularly dangerous situation. And that means the Storm Prediction Center has a high confidence of multiple intense tornadoes, EF2 to EF5, occurring within the watch. SPC's goal is to verify multiple intense tornadoes in 3 out of 4 PDS watches. And you might also get a particularly dangerous situation watch for severe thunderstorms expected to produce winds of 75 miles an hour up. So that's hurricane force. Or hail of 2+ inches. In other words, the significant severe weather. Or perhaps a bow echo moving really, really fast. So just the forward speed of that combined with downburst winds or whatever expected to, if that line's moving, hauling east at 55 miles an hour, that might also prompt this. And this is a typical graphic that you would see posted to social media for that. So let's talk about climatology a little bit. You've seen this in table format, but I just kind of wanted to show you how things compare locally to the rest of the nation. So this is the annual average number of severe watches issued per year for individual counties. So you could see in our area of responsibility, down here, let's see. Never really use the pointer, but anyway, you know where you live, right? So most of our Florida counties, right, you could expect maybe 3 of these per year. A couple counties in Southwest Georgia, a few more times, and those counties in the eastern Florida Big Bend, maybe 1 a year. And you're like, hold on a minute now. I know we get more watches than that, and yes, you do. These are severe thunderstorm watches. So that Tornado Alley states, right, they get the lion's share of severe thunderstorm watches. This is the tornado watch. graphic. Big difference, right? It's not Tornado Alley that gets the most tornado watches a year, but it's right here on the Gulf Coast, particularly Mississippi, but Alabama, Southwest Georgia, Florida. Now you're talking 10, 8 to 10 a year. Okay. Now, this is how geographically things vary with respect to marginal risk. Areas in Southeast Alabama and the Western Florida Panhandle, you're going to get about 34 or more marginal risks a year, more than once a month. Here in Leon County, it's roughly 30, right? Down in Dixie County, 22, 23. So there's definitely a geographic variance in terms of the number of marginal risks you're going to get. More to the west, fewer to the east. This is for slight risks. So in this case, the western fringe of our area is up there around 13 days a year. A good chunk of our area in the orange is around a dozen days. And then, the Florida Big Bend is more like 10. What about enhanced risk? Well, in this case, there's a big gradient here. Coffee County, Alabama, there, our northwesternmost county, they're going to get 2 to almost 3 a year. Leon County here, you're looking at about one time a year getting that enhanced risk day. Now, of course, some years you could get 4 or 5 of them, right? I mean, it varies from one year to the next. And then less than annually there in the Southeast Big Bend. Moderate risk days, I mean, even over there in Alabama, you're getting less than 1 a year. And it's only 1 every several years as you move east. And then the high risk probabilities are so low on the day 2 outlook that these are day 1 outlook statistics. And you're looking at the vast majority of our area in the light blue, like once a decade. Oh, yeah, very, very rare. So let's switch gears to timing now. And there are some challenges involved with timing. And no decision maker wants to hear that, right? I tell you what's really going to happen. We hear that all the time. What's your best estimate? Blah, blah, blah. And we do give our best estimates, but we also give probabilities. And so I'm going to explain that a little bit. So it's important to remember that SPC days run from 7 a.m. to 7 p.m. Eastern Standard Time, or 8 a.m. to 8 a.m. Eastern Daylight Time. So it includes that current day and the upcoming night. And despite the increased demand for timing details for all severe weather events, not all weather scenarios make this feasible. That's just the honest truth about the state of the science of weather forecasting. Now, it is relatively easy for us to time a prefrontal squall line if there is good consensus among the myriad high-resolution models and supercells, individual supercell storms are not expected to develop out ahead of the line. Then we could get a pretty high confidence timing forecast for that. All other scenarios make actionable timing estimates more difficult. Again, this is something you don't want to hear, but it's the truth. Arrival times can vary by as much as 6 hours on the day 2 outlook. So we'll get briefing you out in the late afternoon, day before the event. Keep in mind that things can change. Then there's the scenario that individual supercell thunderstorms develop out ahead of the main line. And those are the ones that can contain tornadoes. You get tornadoes in this main squall line too. As we found out last year here in Tallahassee. And then, of course, there's the fact that the line may be slowing down, speeding up, although the former's more typical situation that happens here, or weakening, and that happens a lot as well. So in some cases, parts of the area are not expected to get severe weather at all. So keeping all those things in mind, we decided to update how we message timing. It used to be we did a deterministic forecast. In other words, the most likely forecast, like you see represented here. So in this case, Southwest Georgia, the Western Florida Big Bend, our best deterministic timing of arrival was 10 a.m. to 2 p.m. In this case, however, we put a disclaimer, say isolated severe storms may occur ahead. So a question we like to get from you all when we get to the Q&A part after this is how broad is too broad in terms of a time interval? How broad is it no longer actionable? All right. So because we understood in the National Weather Service that there are these challenges, caveats and all that for timing, we have updated our risk graphics that we're using now. You're still going to get the most likely forecast. You see that indicated there in the white table spaces there. So once again, it's 10 a.m. to 2 p.m. in the light blue area. But there's now some probabilistic information. Remember the bell curves that Parks was showing you? So if you take that light blue area, the most likely timing for severe weather is 10 to 2. But they could start as early as 7, which I know for schools is a significant time. And while we're expecting the threat to be done by 2, it could be lingering as late as 4. So this is an extra bit of information that you can use based on your level, your risk tolerance, basically, to try to make a more informed decision. So we've issued a few of these timing graphics. Largely, folks appreciate the extra information. And it kind of drives home the point that we're going to do our best to give you a most likely forecast. But I'm telling you, some of the time, it's very difficult to do. I think we went through this already, but there's no reason I can't again. For severe weather operations, we don't do webinars for marginal risks. We issue one email a day. For slight risks, it depends on how, is it a high-end slight risk, like closer to enhanced, or is it a low-end, like closer to marginal? We're going to do a couple emails a day for a slight risk, but we may opt out of doing a webinar, but there's an option to do one. Enhanced risks, we will absolutely do at least one webinar, maybe 2, depending on how bad we think it's going to be. Moderate risk, we will do 2 a day, mandatorily. Same with high. All right, that's the end of severe weather. I suppose I could pause here to see if anybody has a question right now. If you do, hit the hand raise button or put it in the chat. Brian?
Yep. Brian, if you got a question, unmute yourself so we can hear you.
Not hearing you, Brian.
Or maybe type it in the chat, see if we can see your question.
Yeah. That little chat symbol, it's the third icon from the right there.
Mark, you're muted now.
Sorry. So there's my email. If you have any questions that you didn't think of during the presentation, feel free to email me. All of you can do that. We will be sending the slides out, of course, the recording. So let's go to this final segment here. And Brian, if you want to type your question in, by all means. So Weather Prediction Center. Now, the Weather Prediction Center is located near Washington, D.C., and they focus largely on rainfall forecasts. So they also issue outlooks, in this case, excessive rainfall outlooks. Now, there are fewer categories. There's only 4 risk levels instead of 5. So like no enhanced, as you see there. And this ranks the flash flood risk using that 4-tiered system over the next 5 days. So it's not 8 days of outlooks, but there are 5. They also issue mesoscale discussions or near-term discussions, if you will. But the local office does issue any flood warnings, and also the local office issues the watches. Now you remember in the severe weather side of the house, it's the National Center issues the watches, local does warnings. And in flooding threats, the local office does both. So in this particular chart, you see that there's a moderate risk or a level 3 out of 4 up there in Pennsylvania, just a marginal risk, level 1 out of 4 down there in Mississippi, Louisiana, and Alabama. So these are the probabilities broken down for you. Marginal risk means there's at least a 5% chance of sufficient rainfall to exceed the current flash flood guidance, meaning basically there's going to be a 5% chance of flash flooding. Slight risk is 15%. Moderate risk is 40%, and high is 70%. All right. Now, this is an example of the text that could come along in an excessive rainfall discussion. And in this case, it's quite detailed. Now, it's broken down into different regions, and you see there's 2 distinct regions here. And we'll start off with the highest risk area, and then discuss other areas as they see fit. So that's a companion product. So WPC days also run from 12Z to 12Z, which is Greenwich Mean Time, by the way, or in other words, 7 a.m. Eastern Time to 7 a.m. Eastern. So again, for the current day and the following night. Day 1 outlooks are issued 3 times a day at 3:30 a.m., 11 a.m., and 8 p.m. Eastern Standard Time. And then days 2 through 5 are issued twice a day at 3:30 a.m. and 3:30 p.m. So keep those update times in mind. They also issue mesoscale precipitation discussions. Instead of a blue line, you get a hot pink swirly line outlining the area of concern. And within these text products, a typical size of these areas are roughly half the size of Kansas. This looks bigger than that. But they will indicate in the discussion their level of confidence that flash flooding will occur. They could say flash flooding is likely. So in other words, there's a high confidence that the environmental conditions are favorable or will become favorable for heavy rainfall that will result in flash flooding. Flash flooding possible? Well, there's less confidence there. Conditions are favorable or will become favorable for heavy rainfall, but there are questions about how the event will evolve or whether flash flooding will occur. So it's a lower confidence statement. And then flash flooding unlikely. Well, there's a high confidence that conditions are unfavorable or will become unfavorable for heavy rainfall. So these are typically issued towards the end of an event. And here's an example of a mesoscale precipitation discussion. And if you look at the top here, near where that cursor is, when I took the screenshot, it's concerning heavy rainfall, flash flooding possible. So it's that middle lower confidence scenario. And there's a summary of what their thinking is, a more technical detailed discussion here. And then down at the bottom, the local offices that are impacted, TAE is us. And then an option to download a shapefile or a KML file of the area of concern. And that is it. So I'll go ahead and I guess stop sharing. And for the rest of the time here, this final half hour, we wanted to leave time to open things up to y'all. And as I'm sure you've all mentioned at your school, there's no such thing as a stupid question. Oh, Brian, we answered your question. Well, that's great. Yes, you will receive a copy. I know we presented a lot to you today, but you will have the slides as reference. If you want to make absolutely certain that you get a copy of the slides, email me. Because what I'm going to do is I'm going to send the copy of the slides and the recording out to the original email lists that I sent. So if you got an invitation to this personally, you're going to get those things. If you were alerted to this training by someone else and they shared the link with you, I'm not going to know that, right? So, provide your email and I'll make sure you get on that list. All right, so we're turning things over to you all. Do you have any questions at all for Parks or myself?
Yeah, and raise your hand if you got a question. I'm also making sure we can see anything you put in the chat too. So I'm changing some of the settings as we go as well. So we'll make sure we see that. But raise your hand if you got a question.
And also, I am stopping the recording.
Yeah.
So any questions we have, all right, stop.